Good day. Section 6.4 is titled Partial Fractions or Partial Fraction Decomposition. In this lesson, we are going to decompose a fraction. Now, I'm going to go up here and just give you an idea of what has happened in the past pertaining to this. Imagine I take like 4 over x plus 1 plus 3 over x plus 2, and we want to figure out what this equals. Well, in order to do that, we had to get the common denominator, rewrite our fractions, and in the end, we would get an answer like 7x plus 11 over x plus 2 times x plus 1. For example, that's what we would do. So now today, sorry about that, technical difficulties. Today, we are going to take that finished product and we are going to decompose it, break it apart, so to speak. So let's see what happens here. First thing you got to do is find the factors of your denominator. So let's see here. That makes x times x and plus 2 and minus 1. And so what you got to do here then is you're going to say this equals an x plus 2 and an x minus 1. And what we do is put some sort of variable missing value up here, and it's, in this case, it's going to be a constant term, but the rule is what goes in the numerator must always be an expression that is 1 degree less than what the denominator is. We have a first degree polynomial in the denominator, so we put constant terms up here in the numerator. And now we have an equation to solve, of which we're going to multiply the whole thing by the common denominator. We're going to multiply by the common denominator, and we're going to multiply by the common denominator. And when the dust clears, what do we get? This all cancels here, leaving us with 3. The x plus 2's go bye-bye here, leaving us a times x minus 1. The x minus 1's go away here, leaving us b times x plus 2. Now, ultimately, here's what happens. We distribute the a, we get ax minus a. And then we distribute the b, we get bx plus 2b. We're going to combine the like terms ultimately. We have a plus b times x, and then we have minus a plus 2b. Now please note over here on the left side, we have 0 x's plus 3. And what we get to conclude then is that a plus b has to equal 0, and negative a plus 2b has to equal 3, because that's our constant term, and it equals 3 over there. And then when you solve the system equations, you can see that 3b would equal 3. If you add the two equations together, we'll find that b equals 1. Substituting back in, we're going to find that a equals negative 1. And we can complete our problem and write the answer to this problem. The decomposition of these two things is negative 1 over x plus 2 plus 1 over x minus 1. And we have ourselves an answer. All right, let's go at this again. Take a look at this one. Factor your denominator. And then, again, you're going to set it equal to fractions that include each one of your denominators. X plus 3, x minus 3. Each one of those is a linear factor, so you put an a, b, and a c above them, the constant terms. Then we multiply by our common denominator again, which is x times x plus 3 times x minus 3, x times x plus 3 times x minus 3, and keep doing this to each and every one of these. And let's see what we end up with. Now everything cancels in the first one, that's the idea, so you're left with x plus 2 equals. This first one we're going to have a times, goodbye to the x's, but we have an x plus 3 times an x minus 3 left. The next one we have b times, goodbye to the x plus 3's, and we have an x times an x minus 3 left. And then the last one we have c, and then goodbye to the x minus 3's, and you're left with an x and an x plus 3. Now I'm going to do a little magic trick on these now. Instead of doing what I did in the previous one with the distribution, we're going to just say, hey, let's let x equals 0 for fun. All right? Just randomly, let's let x equals 0. If you put x in the left side, you get 2. If I put 0 in this a expression, I get 3 times negative 3, I get negative 9a. If I put 0 into the b expression, I get nothing. And in the c expression here on the far right, I get nothing. And lo and behold, I find that a needs to equal negative 2 ninths. Isn't that nice? And then we're going to go and say, hey, let's just, for fun, let x equal, let's go with 3 this time. X equals 3. Now plug it in on the left side of the equation. 3 plus 2 gives us 5. In this a expression, 3 minus 3 is 0, so that whole thing is 0. The b expression, 3 minus 3 is 0, so that whole thing is 0. And then in the last one, we're going to have 3 times 6. 3 times 6 is 18c, and we find that c is 5/18. And then we'll do it again, just for fun. Let's let x equals negative 3. And when you do that, you get negative 1 on the left side. And on the right side, we get negative 18. Negative 18. No, it's positive 18, isn't it? Pretend that 18 isn't there. Negative 3 times negative 6 is positive 18b. And we find that b equals negative 1 over 18. Sorry, I'm squishing that in at the end there. And then we get to go write our answer, which is going to say something to the tune of negative 2 ninths over x plus b, which is negative 1/18 over x plus 3, plus our a value, let's see here, 5/18 over x minus 3. And again, we have accomplished our goal of decomposing our fraction into what was it that made our original expression. Okay, this next problem has a little bit of a difference to it. It's got a repeated factor in your denominator. When you do this, there's a little different thing that we do. We go and say, hey, we got x minus 1, but we also have x minus 1 squared. We have to list both of these as options. Now, if this was cubed, we would go x minus 1 squared, and x minus 1 cubed. You have to list all the possible outcomes of what that denominator could have been. Keep in mind these are both linear factors, so you put constant terms above them. And again, we repeat our process. We are going to multiply by x minus 1 squared this time. And now we get 2x minus 3 equals a times x minus 1. And then we get b. Just b, because that all goes bye-bye. So now we're going to go and say, hey, let's just randomly let x equals 1 for fun. And that leaves us with 2 minus 3, which is negative 1, equals 1 minus 1, which is 0, times a is nothing, plus b, which is just b. So, hey, looky there. We know what b is. Now I have no other numbers I can randomly pick. Hopefully you've picked up on why I'm picking those numbers randomly. I have to plug that back in and see what I get here now. I get 2x minus 3 equals ax minus a plus negative 1. Now, if you take a look at ax here, that should equal 2x. And therefore, we now know what a equals. Negative 2 plus negative 1 indeed is negative 3. So we know that a is 2. And we get to go finish our problem and say the answer to this question is a over x minus 1 plus b, which is negative 1, over x minus 1 squared. Okay, this one here is quite the doozy. It's got two repeated factors in our denominator. One's a linear factor, one's a quadratic factor. We get to learn what we do with a quadratic factor. You can see what happened here. I've already expanded it. We've got our x squared and our x. They both get constant terms above them because they are linear factors. And then we have our x squared plus 2, which is a quadratic factor. That gets a linear factor in the numerator. Cx plus d and ex plus f. We just got to keep going down the alphabet. We could have another term over here to the right to just keep on going down the alphabet as we go. Anyway, we need to expand this. I'm going to multiply everything by the common denominator. I'm going to pause the video just to make sure I have enough time. I'm going to expand it. When I restart again, it'll be there. Okay, here's the expression factored or multiplied by the common denominator. You're going to have to, check it out and see what is there and why it's there. All right, I'm trying to get this all to fit in on this video in the proper time frame. Anyway, we're going to let x equal 0 because that's what makes x squared equal 0. And that's going to give us negative 12 equaling 0 plus 2 is 2, squared is 4a. The rest of these, 0 is going to make them all equal 0, so they're gone. We know that a equals negative 3. Now this is where things get a little scary. I got to put that negative 3 back in, and I have to expand everything in this problem. So let's do that. It's going to be negative 3 times, and that's going to be x to the 4th plus 4x squared plus 4. This is going to be plus bx times x to the 4th plus 4x squared plus 4. And I'm going to wait to do the distributing here. So cx plus d times x squared. And then that's going to be plus, and then ex plus f. And then that's going to be x to the 4th plus 2x squared. Super fast forwarding to this problem, I distributed and I've listed all the common things, aka I've got all the things grouped together. All right. Now here's the deal, my friends. On the left side it says there are 8 x's. That means that 4b has to equal 8. We come over here and we say 4b equals 8, which tells us b equals 2. From there, we get to go and say, hey, there are 0x to the 4th, for example, over here. So that expression right there should equal 0. There are 0x to the 5ths on the left side, so that should equal 0. There are 0x to the 3rds on the left side, so that should equal 0. There are 0x squareds on the left side, so that needs to equal 0. And there's going to be a trickle-down thing that occurs here, so let's go to the top one. b plus e should equal 0. Well, if b is 2, then we know that e equals negative 2. And if negative 3 plus f equals 0, we know that f would have to equal 3. And we just keep on solving these as we go, and we'll be able to figure out what every letter is and be able to write our fraction as our decomposition as it exists. I'm out of time. Hopefully this helps. I'll be able to help in class more.